So this question gives us two functions and three sets of intervals. And what we need to do is find the average rate of change for both functions on all three intervals. Then we can compare the results. So what we have here are our two functions, x squared and x squared plus 1, that you can see differ by a horizontal translation. So what this question is getting at is, what effect does a horizontal translation have on the average rate of change of a function? Now, this is a little difficult to evaluate visually. It looks like the functions are getting closer together. So you might think that we'll get different results, but let's calculate some values before we start drawing conclusions. So I've made two tables here, one for each of our functions, with the endpoints of the intervals we were asked about as the x values. So to find the average rates of change, we need to find the corresponding y or function values. Then we can find the slopes of the lines through those points. So these calculations are all just substituting into the function. F of 0, for example, would be 0 squared, which is just 0, and that's the same for all three intervals. And so on the g side, g of 0 will be 0 squared plus 1, which is 1. And again, that will be the same for all three intervals here. All right, so if you go through the same evaluation process with the right-hand endpoints that I put in the x2 column, you'll get these results. So now we can find the average rates of change using the slope formula. For example, looking at the first row in the f of x table, the result would be 9 minus 0. That's the difference of the functions. Those are the y values. Divided by 3 minus 0, which is 9 divided by 3, or just 3. Right, now, I won't make you sit and watch me do the same calculation 6 times. Right, you can go and work through them by yourself if you like. But if you repeat those calculations for the other 5 rows, you'll get these results. And a quick comparison shows that the average rates of change are, in fact, the same for both functions. Okay, so what happened with our earlier observation? Well, when we think about the distance between two objects, it's natural to think about the shortest distance. For example, this distance, or this distance, or this distance. Right? Those distances are clearly getting smaller as the function increases. However, that isn't the distance that's used in calculating the average rate of change. That distance is the horizontal distance. So if you pick any x value and look at the difference between the corresponding y values, go over here to 2, it's about here and here, you'll see that the distance does appear to be staying constant, and that's the distance measurement that's used in the average rate of change formula. So there's an important lesson here in relying on your intuition. Intuition is a great thing, and it's a tool that mathematicians need to develop, but you always have to be a little suspicious of it. Intuitive conclusions should be just the starting point in any analysis. The next step is to do what we did here and look at some specific values and see whether or not they support our intuition.